Okay, continuing with MAC 1105. We were on problem number 9, and I was trying to explain to you when we left off in the last video that this -3 is not underneath the radical with the x, and therefore it is not an action that you're going to perform upon the x. You're going to perform this action on the y. This is not a horizontal shift, it's a vertical shift, and therefore I will not be switching the sign. So that's all you're being asked to do in the new graph called g of x. I can write it again down here. You're just going to take the square root of your x values and you're going to subtract 3. So we're using that function that is stated up there. And then if you don't want to think about it in function form, the way it's written right here, then you can, as we just discussed, you could say, okay, I'm going to leave the x's alone. And that's because of where this number is. Since the number is not underneath here, it's something that you're just doing to the y. So therefore, you're doing nothing to the x because there's no number underneath here with the x. In essence, that means leave the x alone, but take the y values and subtract 3. And even though you may not realize that, this saves you a lot of work because instead of taking all the numbers that you're going to use here, this just says leave the x alone. So 0, 1, we'll use the 4. Too many lines, that's good enough. We'll just use those same numbers. We're leaving them alone according to what this says. And on the y values, we're going to take what we already have and just subtract 3. So instead of just picking random numbers, then taking these numbers and plugging in right here, which can, sometimes create decimals. I mean, we've chosen nice ones that aren't going to create decimals because I guided you towards doing that. It makes more sense so that you don't have to touch your calculator. Instead of taking these and plugging them in, figuring out the square root, and then subtracting 3, that's a lot of work. You're taking a square root, then you're subtracting 3. Instead of doing all that every time we plug these in, all we're doing is subtracting 3 off some numbers that we already have because you're using the y values from the parent graph whenever you're doing the new graph. They're just sitting there right in front of you, so you don't need to take square root or subtract 3 because you're not plugging in values to get the new graph. You're only doing that one time for the parent graph. And for the parent graph, it's much easier to plug in because it's just a raw basic graph without any subtractions or additions or multipliers. So, of course, it's really easy always to get the values that are on the parent graph. Whereas the new graph, it would be much more complicated because there's all these additional operations. So you're avoiding all of that. Instead of plugging into that, you're very simplistically just working off of values you already have and doing a very easy operations that are usually just subtraction and multiplication. This is just subtraction. Take the y, subtract 3. Take the next y, subtract 3. That would be -2. Take the next y, subtract 3, -1. No square roots, no additional operation. Very simple. This saves work, being able to read the commands. So now we're going to make this shape again, but using these points. So instead of at 0, 0, we're at 0, -3. That one was at 0, 0. So 0, -3, this is where the stem of this shape starts this time. And it makes sense. This graph has a vertical shift of -3. That means it's this shape, but everything yanked down 3 units. Vertical shift of -3. Then it's 1, -2. So go over to 1, but down to -2. It begins climbing upward. Then it's +4, -1, +4, -1. And you see that it starts going like that. So you have your original graph, which for that one, you did plug in numbers to the function. And then for this one, you just read the commands. What were you being asked to do to x as well as y? Okay, moving to number 10. Now, this one's more of a pain because not only are you adding 6, but you're multiplying by -1. But I want you to see the difference here. If you're really understanding Notice where this number was, not underneath the square root. Therefore, I used it to perform this action, subtracting 3, but on the y's. But in this one, which is why I put these right next to each other, the number is with the x underneath this symbol that groups them together. This it doesn't have to be parentheses that groups your x with a horizontal shift. So anytime there is a number added or subtracted to the x under some kind of grouping symbols, that may be parentheses, it may be a pair of absolute value symbols, it may be a square root symbol. This is known as a horizontal shift. In order to act upon it in the graph, you need to remember to switch the sign. So you're going to be taking your x's and not adding 6, you're going to be subtracting 6. Okay, we're making a game plan of how we're going to get the original graph as well as the new graph. I'm talking about getting the new graph, because the parent graph is easy. You just plug in numbers into the original function. But you need a plan when you're going to get the new graph. And here's the plan. We are going to take the x and subtract 6. Let me move this down because I've just run into my plan. So for the new graph, our plan is to take the x's. Oh, don't forget to switch. So instead of positive 6, we subtract 6. Then I also see that there's this other operation, multiplication by -1, but yet that number is not up underneath here with the x. Therefore, it is an action upon your y. Upon your y value, you are acting upon the y with that value. So we're taking the y values, multiplying by -1. Okay, so let's get the original set of values. And the original set of values comes from the original function, just this raw basic function with no alterations. Again, if you see that you're taking square roots, why not use values that are easy to take the square root of? This will be my x's. Okay, you know when you're designing a graph yourself, you pick whatever you want for x. Except there may be restrictions in the problem that limit you from using certain values for x. And I just discussed in the last problem, then when the problem has to do with a square root, you may not choose negative numbers there. That's what it means that your domain is limited, because otherwise you're going to make this undefined. You're going to toss yourself into the imaginary number plane. And we don't need that because we don't have that here. There'd be nowhere to plot. So numbers that are not negative, like 0. 0 is not negative nor positive. And then I think the rest of the numbers I pick will be numbers that there are easy square roots of. There is a square root of 1. There is a square root of 4. We discussed in the last problem, our calculator helped us out, that when this symbol is wrapped around the x, because that's what matters. What is being done? What operation is being done to the x? If it's being squared, it's a parabola. If there's a square root around it, it's one of those half of a sideways parabola. If there are absolute values, it's a V shape. And you can, remind yourself of the shapes using your calculator, but I want to see the rest of the work. When you plug a 0 in here, you get 0. When you put a 1 in here, take square root of 1, you get 1. When you put a 4 in here, take the square root, you get 2. There I go. I have all the values that are going to get me my first graph, and I already know the shape because I did the shape up here. Sideways parabola going to the right. Okay, so then now I'm going to get my new graph, and you can do it wherever you want. I'll do it down here, I guess. So this other graph is called h of x. And we already said that in order to get points that are on this graph, rather than plugging into this, we just learn how do we tell whether to do an operation on X or Y? And what I've been trying to get into you throughout all these problems is that when the number's with the X, you do it to X, but you would switch the sign for that horizontal shift. And when the number is on the outside of the grouping symbols, not with X, you do it to the Y. So we wrote the plan right here. We already have our plan right here for the new graph. So when we go to do this XY table, we really don't need to plug the values in. We just need to do these things by looking at the parent graph table. So we're going to subtract 6 off of every x value from the parent table. So 0, take away 6, -6. Let's just do all the x's first, because if you jump from this to this, you're going to get confused. Okay, take the next x value. 1 take away 6 is -5. Then the next value in the table, 4. 4 take away 6, -2. I don't need this next one because I just did 3 points. And then now do what we decided we were gonna do to y based on what we saw right there. Okay, so now we're taking all the y's again from the parent table. You're always going off the parent table. That is a lot easier than taking all these values and trying to plug them in there and then multiplying by -1. That's a lot of work. This is much easier to do to get all these answers. Just take the y values you already have, multiply by -1. So 0 times -1, 0. 1 times -1, -1. And then what's that last y value? 2. 2 times -1, -2. So now you have all the points that are going to be on the new graph. Go and plot them. You can plot both of them at the same time. This is going to be your new graph. That comes from this, even though I took a shortcut to getting all the y partners. So you have for this parent graph 0, 0, you have 1, 1, and you have 4, 2. And we discussed that that's the shape. Then for this, to get the new graph, you have -6, 0. You have -5, 1, or -5, -1. -5, -1. And we have -2, -2. -2, -2. Okay, so still half a parabola. Why does this one from the parent graph, why is that upright, whereas this one is going underneath the x-axis? Let's review this a little bit. Whenever, and I was saying this because this popped up in several other problems. This new graph, the blue one that's upside down and underneath the x-axis, it got flipped. That -1 multiplier takes this graph, this yellow graph, and flips it across the x-axis. That's why this one's going up while this one's going down. Okay, also notice that the stems are in different places, the vertex that starts it. This one's at 0, 0, whereas this stem is 6 units to the left, just like I told you. Even though it appears as a +6 in the equation, that really means you're going to be switching that sign, and that's where that new vertex is going to be. The vertex is this little stem where it starts. Okay, so plenty of examples and all the work that goes with it. You should always be able to back up your problems. Don't come into the test. I'm going to keep repeating this. Don't come into the test only knowing how to touch a calculator, because there will be nothing for me to grade. And that means nothing for me to give you points for. You need to be able to back up what you do in the manner that you see me doing here. So when you see these same kind of problems, I'm going to remind you. I'll try to remind you, but really it's your responsibility to read it and realize that you just did a bunch of homework and do them like the homework, where you show the original graph, parent graph, and the translated graph. Likewise here, that's the essence of this entire section. So you wouldn't get to the test and then all of a sudden just give one graph. You give both of them, because then you're showing how the new graph has moved with respect to the old graph. That's called showing a transformation. If you only have one graph, then you can't really see how, the changes that have occurred. And that's it for section 2.5.